So yeah, I'm talking about streaming on the web. And streams, most people I assume in the room are coding with JavaScript these days, at least. So just hands up if you're coding with JavaScript. Fantastic. No, don't put them down, keep them up. All right, put them down, or keep them up, rather, if you're coding on the server side as well with Node. Okay, that's kind of what I expected, so that's fine. So this is not necessarily a Node-focused talk. This has aspects of streaming, because what streams have brought us, and they've really challenged us and made us think about like how we construct programs, I think. Because as Rod sort of talked through, asynchronicity is a hard thing to deal with. Callback hell, I don't really find it too bad, but because I actively avoid it. I think if you just follow the bouncing ball sometimes, you do end up there. But there's lots of patterns, as Rod described, for avoiding that. So the big thing that streams represent on the web is that they represent, or at least from a coder's perspective, is they represent freedom. And freedom to really just get in there and make something fantastic, and then maybe not have to think about how it's all wired together. Or more importantly, you just think about how it is wired together, not how to actually make the whole thing work. A good example of this I actually encountered recently doing the WebRTC stuff. And WebRTC, one component of WebRTC is the fact that you've got peer-to-peer data channels. And that's the ability for two or more computers just to basically speak to each other, across a wire. And this is new tech. This is not something that's ever been designed before, or it's, coming out. And there's lots of libraries that predate all of this. But because some have been built with streaming interfaces, what happened for me at least is all I had to do very little piece of work in building a sort of a streaming adapter for a data channel, which opened up a world of possibilities for me. Basically, I could suddenly send anything that knew how to speak over a stream was suddenly able to talk over a data channel. I had to do a lot of work to make the data channel behave correctly, because essentially you've got binary data and things like that. But at the end of it, it was amazing. Like libraries, if you go and look up a library by Dominic Tarr called Scuttlebutt, it's absolutely amazing. Like synchronized peer-to-peer data store, works straight off. Rod pointed out the fact that there's streams and flow and back pressure. So what I wouldn't mind doing is, John, you just come up here. I'm going to do a live demo, but not in the way that we normally know it. And, yeah, you'll need that initially, and then you'll put it down.
They're sick of me, surely.
So John, just sit down. Sit down at the table. Just sit down there. Okay. So what we're going to do is we're going to show how streams work by not using a computer, because these are grounded in a fairly simple concept of basically, don't turn your back, it's rude. Okay. So we're talking about flow, and the concepts of modularity that Node brings is basically, and we've heard it in web components, this stuff's been repeated and repeated. Do one thing, do it well, and in addition to all that, test the crap out of it, so people can trust it. Because, so John, what we're going to do, mate, all I need you to do is make a plane out of this. I'm a file system, so I'm representing the file system, and you're an operational. You're sending it over the wire. So you're turning this into a plane. Thanks, Shane, for some brochures. So there you go. So it was a streaming interface. What the hell? Come on. So this is, what I'm demonstrating here is what the way streams were originally implemented, and that's basically a push mechanism, where I'd be just the file system, I'd be spitting them out at him as fast as he could. Now John at that point, he could basically say, in the old streams, he could say, stop, stop, I can only do one thing at a time. So and that happens at the point which he receives a plane. So we'll let him finish this one, and then we'll pretend that he doesn't have a whole backup of streams. And this is where he should be pushing back pressure to me. Yeah, exactly. That's back pressure. Sod off, mate. All right, send it. It's not bad. All right, so this time, John, now when I give it to you, and I try, or when I give it to you, you just say, mate, thanks, and then,
thank you.
All right, and another one? Okay, right. That's good enough. And that's basically where streams were in Streams 1. What happened in Streams 2 or Streams Next, and Rod's much more an authority on this than myself, so go and have a chat to him. It's easy. I'll talk about other things. What happened next is that they changed the interface around to be basically a pull-based mechanism. So rather than me go and spit stuff out, I would indicate that, yes, I'm in a readable state. I have some paper that John can come and get if he'd like to make a paper plane. You're real. You're yeah, okay. No. We've changed. We're in now Streams 2 land. Okay, I am now readable, John. I have paper. No, you can. Yeah, ask me. That's fine. You say I wouldn't want you to have to get up. No. Okay. So you came. So basically, I indicated there was stuff here, and he came to me and got the data, and now he's starting to move that through. And this concept of streams can have lots of steps along the way. I was thinking of a far more complicated example where someone would scrunch the paper and someone would have to unscrunch the paper and then someone would throw it, but I figured that wouldn't be very good for aerodynamics. So we've gone away from that. What? It would waste paper. They're perfectly good brochures. We don't want to waste them. So I think as far as providing a visual context for the way streams work, that kind of helps a little bit. And John, if you do want to keep making planes, let me know. I won't be distracted by it, so... There is. So... All right. So I think rather than me try and go through traditional NodeStreams and that journey, there's a lot of information out there already. And John Reisig, who obviously wrote jQuery, has provided because he was sort of dancing around the edges with streams for a while, and then I think he sort of looked at it and went, you know what, this is really cool. So he's put together a little site called NodeStreams.com. That's right. Which is a really expressive way of basically just being able to play around with that in an interactive way, and it will actually show you the code it generates. So rather than me show you that code, I would say go there and have a look. The thing I want to do, well, I will talk about this. So this is getting streams to the web. So you guys are mostly front-end devs, or you're not working with Node. So you might have Python or whatnot out there. Let's say that you are a Node dev and you want to use these sort of patterns of abstraction in both places. We can definitely do that, and I think because we don't have a specific Browserify talk, it's our duty for anyone who is using Browserify to give it a shout out, as Raquel did, because it's an amazing tool that kind of just liberates you from everything that you know to be a pain in your development process. So as much as grunt and gulp and things help, I would just say just use Browserify and then whatever other tools you need. So an example of how Browserify works, if I was to take an empty file, Browserify has a look at this, generates it, and I'm just showing you the amount of bytes generated to give you an example of, to give you some context to how much making a node ecosystem in the web does actually add. And it does start to stack up. As soon as I include the stream module, unfortunately I'm over 100K just to get the logic that's required to bring in streams. So I know a lot of us are trying to create fairly lean things, so that's probably less than ideal. I don't think it should be like throw the baby out with the bathwater. If, like, for me at least, I think the trade-off is worth it in some situations, but it's something we should consider. And essentially, the root cause of that, or one of the causes of that, is essentially this binary representation of a buffer which Node has, because most of this stuff obviously started with file system-like things. So everyone's sad, high byte count, not happy. So what I really like is when people start thinking differently to the way everyone's sort of talking about. I think it's fine to follow the hack and use kind of things. There's something cool and stuff, but the stuff I really love is the stuff that is out there and is not being talked about that much. And one of the things is in case in point is Hoodie. That's a great project that people will get on board with. Another one's Dimitri's Eve. And added to my list pretty recently is a thing called Pull Streams. Once again by one of the people I call like the heroes of streams is a guy called Dominic Tarr. So Pull Streams, in terms of their overhead, they're pretty light. It's about 18K, and what it does is basically say all of this stuff that goes around streams boils it down to a very sort of core abstraction around, it's just functions passing and things like that. So instead of having to have objects throwing data and listening to event emitters. It just says, here's some constructs. They do your head in writing them, but they're lovely to use. So here's an example of how pull streams kind of look in Node. The traditional, you might have seen it if you haven't seen it already, but you will see it if you go to that stream playground, is that you basically have thing, pipe, thing, pipe, thing, pipe, thing in the sort of the traditional way. Whereas pull streams, and this is kind of formatting to my own tastes, but essentially I bring in the pull streams module, that's not the right module name, but if there's a module called pull flicker, which I sort of wrote to experiment with, and then basically I'm saying, okay, well, setting up a pull stream, which is pull from this source and just log it out, just to see what I'm getting back. So from someone looking at what's been done, so not having to say, you know, because in that example that Jared gave yesterday about the people sort of tracking complexity in code, I think that's pretty easy to follow. I think you can kind of get an idea of what's going on without having to dive in. And I think that brings a point in code complexity that, and something that's great in the Node module, sort of the module aspect or way of coding, is that if you hide the implementation, you trust it more. So I think modules are a good way to go in terms of managing complexity. So, and here's, okay, the same kind of code, but instead of just pushing it out to the console, the results, I'm now using what's called a pull sync, which is what the log was as well, and I'm sending it out to a server-send events endpoint. So I'm suddenly now taking server-side data and I'm enabling this kind of transmission to the web. This is a slightly more complicated one, and that's one of the things that you may not know about Rod is he's written an excellent adapter to a database called LevelDB. And this is an example of where we're using some of these kind of functional concepts, such as map and filter, which basically map says, turn it into another thing, as Rod demonstrated, and filter is a similar concept that says, either keep it or chuck it away. So if you filter return true, it's going to be kept in the bunch of stuff that goes through, or you return false to essentially reject it. And what this is saying is, as the database is changing underneath, listen to all the changes, return the value of that because I'm getting also the key that's been put into the database. It's a key value store. The filter's there purely for demonstration. It's just saying return true, but you could make a decision based on the content of the data, and then finally pass it to this pull SSE endpoint, which then sends it over server-send events. And then there's a nice kind of other side of the coin, which is, this is on the client, which is once again using pull streams and the server-send event thing, but this is the client this time. And now it's saying pull from this endpoint and just log it. So let's see if we can pull together. So, I mean, this is essentially it. It's nothing fancy, but you can see these are the readings of the node sort of CPU. So there's a little thing called OS CPU. I've got one process just sitting there writing it to LevelDB, and this other process doing exactly this. And I just feel personally like this code is really easy to manage and really easy to understand. The one warning I'll give you before you embark on any streams journey is they're addictive. Once you start working with streams, you don't want to work any other way. And I've certainly found that to be true of pull streams especially. I just want to do everything with pull streams now. And that's obviously not possible, but for the most part, you can actually start to reason about how your software might work with those things. And that's it. Yeah.